Hello everyone, how are you all? In this video, we will be discussing some special right triangles. So, what are the special right triangles and the trigonometric ratios and the values of the trigonometric ratios of the trigonometric ratios of the special right triangles we are going to discuss in this lesson. This one you see here, the isosceles right triangle, that is 45 degrees, 45 degrees, 90 degrees right triangle, and another triangle is 30 degrees, 60 degrees and 90 degrees right triangle. So, here we are going to say how the trigonometric values of our trigonometric ratios are defined and what are the values for these trigonometric ratios we will be discussing. Look here, let us assume the equal side, the measure of the equal sides of the isosceles triangle is x units. So, here AB is x is equal to BC, that is also x units. Now, we need to find the hypotenuse here. Hypotenuse is AC, which is opposite to right angle. Here, using the Pythagoras theorem, we have AC square is equal to AB square plus BC square. And AB square is as x, BC also x, we will put these values in this rule. When you put and simplify, you will be getting 2x square is AC square. In order to take AC value, we need to take the square root. Square root of 2x square is square root 2 times x. So, AC hypotenuse we are getting as square root of 2x units. Now, let us consider an equilateral triangle. Each angle of an equilateral triangle is 60 degrees. So, all the sides are equal, so all the angles also equal. So, here when you draw a perpendicular from the opposite vertex of side BC, it is called a height of the triangle or altitude of the triangle. So, this will divide the side into two equal parts. Suppose if a side is having 2x units, then half of that will be x units, and once when it divides this BC into two equal parts, it is also making a right angle at D. That means we are getting triangle ADC as 30 degrees, 60 degrees and 90 degrees triangle. So, as I say, this will divide the angle also in equal parts. So, 60 degrees will be converted into 30 plus 30. Here side also will be divided into half. So, we are considering first 2x units, and now the half of the 2x is x units. Let us assume that this triangle here. Now, we need to find the altitude of the triangle. So, as it is 2x units and this is x units, and now we can apply the Pythagoras theorem for this right triangle. Here AC square is equal to AD square plus BC square, and we need to find AD square. AD square is equal to AC square minus DC square. Here AC square is 2x square minus x square. It would be 4x square minus x square, that is 3x square. But we need AD. AD is taking square root, we will get that. AD is equal to root 3 times x. So, AD is root 3 times of x. Once you get the all values of a right triangle, lengths of sides of the measures of the sides of a right triangle, you can find any trigonometric value. For example, we know opposite side and adjacent side and hypotenuse of this right triangle. Let us see the value of sine 45 degrees. As using the basic definition of 45, opposite to 45 degrees over hypotenuse, the opposite side to 45 degrees is x here, and over hypotenuse is, as we have calculated it as square root of 2x. So here the common factors can be cancelled. So the value of sine 45 is 1 by square root of 2. Similarly, you can calculate the value of cos 45. Cos 45 basic definition, adjacent to 45 over hypotenuse. Adjacent to 45 is x, hypotenuse is square root 2x. X gets cancelled, then you will get the value of cos 45 as 1 over square root 2. Similarly, you can calculate tan 45. Tan 45 is equal to opposite over adjacent. Opposite side is x and adjacent also x. X gets cancelled, the value of tan 45 is 1. Once you know the values of basic trigonometric functions, you can find the reciprocals of these three functions to calculate the remaining three. The reciprocal of sine 45 is cosecant 45. So the cosecant 45 value will be the reciprocal of 1 by square root 2. That is 1 by square root 2 is square root of 2 over 1, that is square root of 2. Similarly, the reciprocal of cos 45 is secant 45. So here we will calculate the secant 45 value. It will also be square root of 2. Same way you can calculate or find the value of cot 45. Cot 45 degrees will be reciprocal of 1, that is again 1. Here we got all the trigonometric ratios of this special triangle 45 degrees and 90 degrees. Now we see the special right triangle values for 30 degrees, 60 degrees, 90 degrees. Here sine 30 degrees is equal to opposite over hypotenuse. Opposite to 30 degrees is x over hypotenuse is 2x. That value is 1 over 2. Same way, cos 30 degrees is equal to adjacent over hypotenuse. Adjacent to 30 degrees is square root of 3x over 2x, that is equal to square root of 3 over 2 is the value of cos 30 degrees. Same way, opposite over adjacent is tan 30, that is x over square root of 3x. X gets cancelled, then we will get 1 over square root of 3. Tan 30 1 over root 3. Similarly, if you want to find the cosecant, secant and cot, these are the reciprocals of sine, cos and tan. So let us find the reciprocals of these values. 1 over 2 reciprocal is 2, cosecant 32, secant is 2 over square root of 3, and here tan 30 is equal to only square root of 1 over root 3, that is cot 30 is the reciprocal of the value. Same way we can calculate the values for 60 degrees. Sine 60 degrees. Sine 60 degrees is equal to opposite over hypotenuse. Opposite to 60 is square root of 3x and hypotenuse is 2x. When you simplify, you will be getting square root of 3 over 2. Sine 60 is root 3 by 2. Same way, cos 60 is equal to adjacent over hypotenuse. Adjacent to x, that is 60 degrees, is x over hypotenuse is 2x. We will be simplifying, it will be simplified to 1 over 2, that is half. Tan 60 is equal to opposite over adjacent. Opposite to 60 degrees is square root of 3x over adjacent is x. X gets cancelled, you get square root of 3 is tan 60. Same way, you can calculate the reciprocals of these three basic trigonometric functions, like cosecant 60 is 2 over square root of 3 and secant 60 is 2 and cot 60 is 1 over square root of 3. Here we have derived all the trigonometric ratios for the special triangles. I hope you understood the special triangles and the trigonometric ratios and the values of the trigonometric ratios. If you like the video, you can share it and subscribe to my channel. Thank you for watching.